Now what you'll see next in your note is that there are steps to preparing a solution. And we're going to review that, and you're actually going to prepare your own solution for an upcoming lab. What we'll discuss next is how to do a dilution. So in the lab, there are two main ways to make a solution. Sometimes we'll make a solution by taking a solute in its solid form and dissolving it in a certain amount of solution. Or we already might have a solution of a certain concentration, and we might want to use that solution, referred to as a stock solution, in order to prepare a solution of a different concentration. If we're going to use that method, what we're going to be doing is what is called dilution. So we're only going to be able to prepare a solution of lower concentration, and we're going to be diluting it. So we're going to be adding water to a certain amount of that solution in order to prepare our new solution. So let's look at a visual here. We've got this solution here that's got a certain number of moles in a certain volume. And what we've done to prepare this second solution is we've increased the volume of the solution by adding water. If you count, you'll see that the actual number of solute particles in both solutions are exactly the same. But when you think about the concentration formula, C is equal to N over V, if we change the volume, if we increase the volume, that's going to decrease the solution's concentration when we keep the number of solute particles the same. So let's investigate this. Suppose that this solution has a concentration of 5 moles per liter. So it's a 5 molar solution, and the volume of it is 1 liter. And suppose that this solution has a volume of 2 liters. What we've done here is we've taken the moles that are in here and we've put them in a different volume. So we can calculate using moles is equal to the concentration times the volume. And what I'm going to do is use the little subscripts of 1 to represent that this is my solution 1, so my solution before the dilution. The moles that I have in this is equal to 5 because I've got a concentration of 5 and a volume of 1. So I started with 5 moles in this solution. And what I've done is I've transferred the moles into this solution. And so now the concentration in here is equal to the moles in here divided by the new volume. So my new concentration here, I've got the 5 moles, and I'm dividing by 2 liters. So I end up with a concentration of 2.5 molar. Now again, some of you might have seen that right away. If you double the volume, you're going to half the concentration. You're not always going to be working with such nice numbers though, so it's important to understand the concept here and how to work with formulas in order to solve when you have more complicated numbers to deal with. So in this case, we've solved for our new concentration by doing 2 steps. We figured out the moles that we have that are in our new solution, and then we were able to solve for our concentration using our concentration formula, N over V. Now when you're doing dilution, because the moles that you have from your original solution is actually the same as the moles in your final solution, there's actually a quicker formula that can be much more efficient. And it comes from the fact that we know from over here that the number of moles that I have is equal to C1 times V1. So the number of moles in solution 1 is the concentration of solution 1 times the volume of solution 1. In this solution, I can say the same thing. The moles in solution 2 is equal to the concentration of solution 2 times the volume of solution 2. Now, because we are diluting solution 1 to prepare solution 2, and the moles that we had available in solution 1 are the same moles that we have in preparing solution 2, what we know is that the number of moles in solution 1 is equal to the number of moles in solution 2, and therefore what also must be true is that C1 times V1 must equal C2 times V2. So let's look at the same scenario using this formula instead of doing 2 steps. We knew that our concentration of our solution 1 was 5 mole per liter, and that our volume of solution 1 was 1 liter, and we didn't know our final concentration, but we knew that the volume of the final solution was 2. So when we do this math to find the C2, we're doing 5 times 1 and dividing by 2, and we're left with 2.5 molar. So whether we solve in 2 steps or whether we solve in 1 step using the dilution formula, we get the same concentration of our final solution. Now it's important to understand the concept, but we will use the dilution formula to solve most problems. My biggest piece of advice for solving these problems is to do your best to try to imagine the scenario and try to think about, if you were doing this in the lab, what would it look like? So in example 1, we have a solution of sulfuric acid that has a concentration of 2 molar. So this is my starting solution with concentration of 2 molar. And I want to know what volume I would need in order to make a solution that is 0.1 molar and 100 milliliters. So I know my final concentration and my final volume, and I would like to know how much of this solution I will need in order to prepare this. So when we look at this, C1V1 equals C2V2, I'm trying to find how much of this solution I'm going to use in order to prepare this solution. So my V1 is going to be equal to 0.1 times 100 divided by 2.0. And what I find is that my volume is 50. And the units of my volume are milliliters, because when I'm using this formula, I used 100 milliliters for my volume. So therefore, the units of this volume are going to milliliters. Now this is very similar to some of the gas formulas that we use, where we said it doesn't matter what the units are as long as they match each other. So if you feel like you're going to forget when you're using the C equals N over V that you must use liters, then it might be in your best interest to just always use liters when you're dealing with volume. If you can handle flipping between the two and knowing that here you have a choice as long as they match each other, then go for it. Okay, so let's think about what this means. This means that I need 50 milliliters of this solution. Okay. And then the rest of the 100 milliliters is going to be water. So to prepare this solution, I'll take 50 milliliters of solution A and I'll add water to make it so that I have 100 milliliters of solution. And that is a diluted solution with a concentration of 0.1 molar. Example 2. What is the molarity of a solution prepared by diluting 55 milliliters of 1.25 molar cobalt chloride to 100 milliliters? So basically what I'm doing is I'm taking 55 milliliters of this solution, and then I am adding an extra 45 milliliters of water, and I'm getting a new solution of a diluted concentration. So this is my C1, this is my V1, this is my C2, and my V2. So reading the question and deciding what is your initial concentration, what is your final concentration, what's referring to the starting and the final scenarios is the most challenging part. Okay, and it takes practice in order to get really good at it. And again, trying to imagine it, imagine what the scenario would be in the lab is the best way to get good at it. Okay, so we've got 3 significant digits here, so our molarity is 0.688. And what we're going to be doing is we're going to be doing an experiment where you have an opportunity to make your own solution from a solid, and then you're going to prepare a series of dilutions. So you'll get really good at the skill, and you'll see how the calculations come into play in order to do dilution.